Well, hello. My name is Alonso. Here's my teammate Jaime, and we're gonna explain, or we're gonna go over some important stuff about our project here for the sensors and signal conditioning class. So right here we have our main project for the class, which is a vigilante robot, or it's a vigilante robot. The main purpose of the robot is that you will leave it either at your house or at a storage house, and it'll go around avoiding objects, and then it'll gather data from the main sensors that we have here. This is the MQ2 sensor. It's a hazardous gas sensor. We have the DHT11, which is temperature and humidity sensor, and we also have the SHARP sensor, which is an infrared sensor that indicates the distance of the objects, and it's the main part of the system, of the logic for the system avoidance. And then we have the MPU60 sensor that's over here, which controls this servo motor. So basically it keeps the camera stabilized as the robot moves, and it keeps it horizon level. We also have right here, if you can see it, we have an LDR sensor, which indicates the level of luminosity on the room, and it would activate this LED, so it would give us sort of like a flash for the camera. And yeah, the SHARP sensor, as I said, it helps avoid objects, and it controls these 4 DC motors that we have over here. Here's the main power or battery of the system, which is 11.1 voltage battery, and we have here a voltage regulator, which also helps us filter the current signal, so it doesn't fry our sensors. And we also have this buzzer right here that it activates when the MQ2 sensor or the DHT11 sensor reach a threshold. So for DHT11 it's 40 degrees Celsius or 45% of humidity. And for the MQ2 sensor, we have a threshold of 3,000 units. And then we're going to transmit all the data that the sensors, these 2 sensors are reading via MQTT. It means via Wi-Fi to a router that we had over here. And we'll see the data in real time as the robot functions. So we're going to put it to the test.
So we start just by connecting the battery, the LiPo battery, which is a 3S battery. So we connect it to the buck-bus converter, and we start just by pressing the push button, so that the ground is connected to the rest of the circuit and the electronic stuff starts working. So we're going to start. So the main objective of this obstacle avoidance robot is that all the objects that are detected are near the static, so that it can't collide with any object. So as you can see, if there is an object that is just static, it avoids the obstacle. So now we are going to see that it performs in real time because it was programmed in FreeRTOS, so that it can perform several tasks, but with also the grid management in real time of the sensors. So like what this means is that if it goes driving, it can also perform some other tasks like the control of the light with our LDR sensor. We can also perform the monitoring of the data via Wi-Fi with our MQTT protocol, which can be seen in Adafruit. And also we can see the camera just by connecting to the Wi-Fi.
Yeah, the Wi-Fi network of the camera.
Yeah. So when the camera is forward, we can see the video. Wait. So we can also see the camera, and also we can perform the task of controlling the position of the camera, which is made by the servo motor, by the inclination of the detected by the MPU signal, by the MPU sensor signal, and then we can see also the data that is sent by the microcontroller every 30 seconds. So as you can see, today is 1:02 p.m. So the last the last read was at 1:01 p.m. 38 seconds. And also we can see that it can perform the real-time. We can see that also it has an alarm that performs in real time, and it doesn't interfere with the data sent via Wi-Fi. So we can also see that it is performed by the buzzer, and also it can be performed the same alarm by the MQ2 sensor, which is about the parts per million gas detected in the environment, also the temperature, the humidity, and it also can be seen in the. It also can be seen here. Yeah, here we see like the point where that reaches the alarm and also the big one. So that's the whole thing about our project.
Yay!